Okay, this is 3.1 and 3.2 notes. First of all, let's look at polynomial functions and their graphs. It says a polynomial function is a function with one or more terms whose exponent is non-negative integers. So it doesn't matter the order of your polynomial, but let's look at the one with the biggest exponent, and that's the one I'm going to look at. This tells you your degree, so the exponent is going to be 5. Your leading coefficient is going to be 3. And then your constant is going to be the number without a variable with it, so this is going to be -6. Okay, it says the graph of a polynomial function is always continuous, smooth curve, and the domain goes from -infinity to infinity. This is important right here. You're going to be hearing me say this a lot. It says in behavior. This describes what happens as x goes to infinity and as x goes to -infinity. So let's say as x approaches infinity, what does your function approach? Well, your function is going to also approach infinity. So I would say my end behavior is going to rise to the right. So as x approaches -infinity, my function is going to approach -infinity. So I would say that it's going to fall to the left. And again, this is my end behavior. Okay, it says the end behavior is determined by the degree of the polynomial. And remember, the degree is the biggest exponent. Sorry about that. Biggest exponent of the polynomial and the sign of the leading coefficient. So a positive leading coefficient is going to rise to the right. A negative leading coefficient is going to fall to the right. An odd degree is going to be an opposite behavior on the left, and an even degree is going to be the same behavior on the left. And I'm going to show you some different ways to memorize this, or not memorize, but how I can show you this in class. Determine the end behavior of the following polynomials. Okay, an odd degree, and this is negative, so just like something to the third. And I know x cubed goes like this, and so any x cubed or 5 or 7 or 9, all is going to look like this. It just changes the number of humps that it goes through. Okay, so since this is negative, this is now going to flip. So it now looks like this basically. So it looks like an opposite of a cube. So I'm going to say as x approaches infinity, my f of x approaches -infinity. So that would be a fall to the right. If you kind of know what the graph looks like, it helps. Okay, as x approaches -infinity, my function is going to approach infinity, and this is going to be a rise to the left. Okay, this is a even, and I know any even is going to fall, it's going to look just like a parabola. It's just going to be, the humps in the middle are going to change. And so this is positive, so it's going to be up like a goalpost. So I'm going to say as x approaches infinity, my function approaches infinity. So this is going to rise to the right. And remember, inside the parentheses here is my end behavior. Okay, as x approaches -infinity, my function approaches positive infinity again. So this is going to rise to the left. All right. If p is a polynomial and c is a real number, the following are equivalent. So c is 0 of p, then blank is the solution of the equation p of x equals 0. So this is going to be c is the solution. Blank is a factor of this, so I'm going to say x minus c. This is going to be a factor. And what is an x-intercept of this? So this would be c of 0. C comma 0 would be an x-intercept. All right. The intermediate value theorem for polynomials. So what is the intermediate value theorem? If p of a polynomial function, p of a and p of b, have opposite signs, then there exists at least one value, c, between a and b, for which p of c is equal to 0. Okay, let me do a little sketch here so it kind of makes sense. Basically, if I have an a and I have a b, and it says you have a p of a and a p of b. So you basically have a function that goes through this, and you have a p of a, so you have a y value, and you have a p of b, which you have a y value here, so p of b. They're saying if you have a function that goes through this and it has an opposite sign, so you have a positive and a negative, or a negative and a positive, then you're going to have a c value, which is equal to 0. Okay? And that has to be your c. That's all that means. Fancy words for nothing really. All right, it says given f of x, given your function here, it says find the zeros, determine the end behavior, and then sketch a graph. So the first thing I want to think about is that this right here, just to give me an idea, this is going to look like a parabola, except this is a negative, so this is going to look like this basically, except I told you the number of humps is going to be different. Okay, so to find the zeros and everything, let's start simplifying this. So I've got negative 2x to the 4th minus x cubed plus 3x squared, and I'm going to set that equal to 0. To set that equal to 0, that helps me find the zeros. So I'm going to see if I can factor. And it looks like I can take out an x in all of this, and I'm going to take out a negative. So I'm going to take out a negative x squared, which leaves me with 2x squared plus x minus 3, still equal to 0. And I can factor this inside here. So this gives me factors of negative 6 that add to give me 1. That's going to be 2x plus 3. I'm skipping some steps here. And this is going to be x minus 1. Set each of these equal to 0. So I've got negative x squared is equal to 0. I've got 2x plus 3 is equal to 0. And I've got x minus 1 equal to 0. This is just 0. Solve this, I get negative 3/2. Add 1, I get 1. So my zeros here are 0, 0, negative 3/2, 0, and this is 1, 0. So I have 3 of them. Now what you have, what noticed here is that because this was squared, this is going to be a double. And we're going to look at that here in a little bit because of the square. Okay, the next thing says determine the end behavior. Okay, we've already drawn a picture that's going to help us out here, so that we can go ahead and write that out. As x approaches infinity, your f of x is going to approach negative infinity. And as x approaches negative infinity, your function is going to approach negative infinity. So this first one is going to fall right, and the second one is going to fall left. So I have this sketch right here at the very beginning. C says sketch a graph. Okay, so I've got my intercepts here, which is going to help us. So let's draw a little sketch here. I need to sketch 0, 0, or plot it, I should say. I've got negative 3/2 and 0, so that's 1, here's 2. So I'm going to say it's about right here. And then I've got 1, 0. Okay, I know my end behavior goes down and down, so I know it's going to go through here and go down, and I know it's going to go through here and go down. Now I said the number of humps is going to be different here. So I know I've got to go up, I've got to come through this, and I said this right here is a double, meaning through 0, it's going to touch it, but it's not going to go through it. So I'm going to go up through here. I'm going to touch 0 and go back through right here. Let me tell you this little hint here. Your leading exponent is a 4, so that means I'm going to have 3 humps. It's always going to be one less than your leading exponent there. Okay? Okay, let's try another one. It says sketch a graph of x to the 4th. Oh my goodness. So this is not multiplied out, but I don't want you to multiply it out. So we're going to do the same thing that we did before. I want to figure out like what this graph looks like. So I've got an x to the 4th, an x to the 3rd, and an x to the 9th. So I want to figure out what my x is. So it's x to the, this is an x to the 9. Okay, earlier I said all odd figures, odd exponents look basically like a cube. I have my leading coefficient is going to be, this is a 1, this is a 1, and this is a 1. So it's positive. So it's going to look to the right. Okay? So I would say as x goes to infinity, your function goes to infinity. Okay? So as x approaches negative infinity, your function goes to negative infinity. Okay? So like I drew here. All right. Let's go ahead and find our zeros, which will help us sketch our graph. This one is set up really easy since I've already got it factored for you. So you can say x to the 4th is equal to 0. You can say x minus 2 cubed is equal to 0. X plus 1 squared is equal to 0. Get 0. So your x-intercept is going to be 0, 0. This gives you x equals 2. So this is a 2, 0. And this gives you x equals negative 1. So this is a negative 1, 0. Okay, now I told you your humps are going to be one less than what you have. So I'm going to go ahead and write that over here. My hump is going to be 8. It's one less than what I have. Okay, let's do a sketch here and see if we can come up with this. We have a 0, 0 that we're going to hit. We're going to hit 1, 2, and we're going to go through negative 1. Now, do we have any that we're going to hit twice? Like before we had a double root basically. So we hit that point twice like this. We have a double root. So we're going to hit that twice. Any square looks like this, right? So that's an x, that's a parabola. So this is either going to look like this or like this, right? So at negative 1, we're probably going to look like some like of a parabola. At this one right here, this is a cube root, right? So cube roots look like this. Fourth root. Remember, fourth roots again look like this again. It looks like parabolas. So from this last, I'm going to go in behavior is this. And from this point over here, I'm going to end behavior. I know I can do that. Okay, at 2, we know at 2 it's going to look like a cube root. So it's going to come through up here and it's going to go down. So there's my cube root. Okay, it looks kind of crazy. Then from here, it looks like we need to do, remember at 0, 0, it's either going to go up here or it's going to come down. So I'm guessing this is going to be a down. Then at this point, this was at negative 1, and this was either going to be a parabola up or a parabola down. I'm guessing this is going to be a parabola down. That's the best point that I could do there. Okay, there's our picture. All right, it says determine the number of local extrema for each function. Extrema means max or min. Okay, remember I told you that all you have to do is look at your leading, your biggest exponent and do down 1. So this is going to be 3, this is going to be 4, and this is going to be 3. Just as easy as that. Okay, 3.2, dividing polynomials. We're going to divide the bottom into the top. So the first thing I'm going to do is write 2x squared minus x plus 2. And then I'm going to put this top number inside, making sure that all your exponents are decreasing by 1. And if they aren't, then you need to fill in, like here I don't have a cubed, so I'm going to fill in a 0x cubed. You can fill in a 6x squared minus 3x to the first is fine, and then plus 1. You don't have to put the 1 though. All right, when I'm dividing, this is what I do. I take my first number, and I see what do I need to multiply by 2x squared to get the 8x to the 4th. And that's going to be a 4x squared. So that gives me 4x squared. You're going to multiply the 4x squared by all of these numbers. So 4x squared times this gives me 8x to the 4th. 4x squared times negative x gives me negative 4x cubed. You notice the exponents are lining up. 4x squared times 2 gives me a positive 8x squared. Now, I'm going to draw a line, and change all my signs. Okay, now this cancels. I end up with a 4x cubed and a negative 2x squared. I'm going to bring down my negative 3x. Okay, same process. What times 2x squared gives me 4x cubed. And that should just be a positive 2x. Multiply 2x times each one of these numbers. That should be a 4x cubed minus a 2x squared plus a 4x. Same process, draw a line, change all your signs. And that's super important to change all your signs. This cancels, and I end up with a negative 7x, and I bring down my positive 1. Okay, now what times 2x squared gives you negative 7x, and there's nothing. So I'm done, and I can write my answer. I'm going to bring this down, so this is 4x squared plus 2x. Bring your remainder, so this is negative 7x plus 1, and you put it over what you divided. So this is 2x squared minus x, and this is plus 2. And that is your entire answer. Okay, this one says use synthetic division. I don't know if y'all remember this, but I know this will be your favorite one. So this is what's on the outside of the division problem. And so when you're using synthetic, you whatever's in your parentheses, you take the opposite. So you're going to take your positive 3. You're going to take your coefficients, again, making sure that you have all exponents that are decreasing by 1. So you're going to take a 2. So here's my 3. I'm going to take a 2. I'm going to take a negative 7. I don't have a 1 there filling in, so I'm going to put a 0 to placehold it, and then I've got a 5. Okay, for synthetic division, you bring down your 2. You say 3 times 2 is 6. You subtract. This is negative 1. 3 times negative 1 is negative 3. Subtract. Well, you're actually adding, but since there's negatives, you're subtracting here. So this is negative 3. Multiply times this number. This is negative 9. This gives you a negative 4. This is your remainder. This is how you write this. This is your remainder, and I always go backwards. If this is your remainder, this is your remainder, this is your constant, this is your x, this would be your x squared. So you would say this is 2x squared minus x minus 3 plus a negative 4 over what you divided into, and that was an x minus 3. Writing it exactly like I did my problem before. The remainder and the factor theorem are pretty much the same thing. What you're looking for, it says if you have a polynomial, p of x, so if I had p of x, I'm going to make this simple, 2x squared minus 1. And I told you I wanted you to plug in a 3. The remainder theorem, all that does is you plug in a 3, and you find out what the remainder is. Okay? So the remainder of the value of p is c. So I want you to find out what the remainder is. So 3 squared times 2 minus 1, and figure out what that remainder is. The factor theorem, the difference between the factor theorem is I want to know if your remainder is 0. Okay? So if the remainder, and you can use this same process. If the remainder is 0, then your x minus c is a factor. So if I were to get 0 here, then x minus 3 is a factor of this polynomial. Looking at number 3, it gives you a polynomial, and it says p of negative 2. You could plug in negative 2 here and use the remainder theorem and see if it is a factor. I'm going to use synthetic division. So I've already got negative 2. Make sure all your exponents are decreasing by 1. I'm going to use my coefficients. So 3, 5, negative 4. I don't have a 2 here, so I'm going to plug in a placeholder, 0, 7, and 3. Bring your 3 down. This is your remainder. Okay. It says find p of negative 2. So basically what I'm saying is that negative 2 is, since this is not 0, x plus 2 is not a factor. Okay, let's look at this one. It says if x minus 1 is a factor, that means if you plugged it in and got a 0, it would be a factor. If so, use it to completely factor. Okay, let's look at this one. This is our last one. Okay, so first of all, there's a couple ways you can do this. You can use synthetic division, or you can just plug 1 in. So let's do some different things. Let's use the remainder theorem. So I'm going to plug in a positive 1. So this is 1 cubed minus 7 times 1. Since this is so easy, so this is 1 minus 7 plus 6. So this is 0. So it is a factor, since I got 0. Okay, since it is, it says use it to completely factor. So now I'm going to use synthetic division. Remember, you always do the opposite, making sure your numbers decrease. So I'm going to have to use a 1, a placeholder, 7, negative 7, and 6. Bring this down. Remember, this is your remainder. Okay, this is your constant, this is your x, and this is your x squared. So I can say x squared plus x minus 6. Okay, I can factor this further. So this is going to be what? X plus 3 and x minus 2, because it said to factor it completely. All right, I know that x minus 1 is a factor, and I know these are also factors. So I could say, I'm just going to tag this on, that this function is totally factored right here. Okay? We could graph this if we wanted to. Let's go ahead and do that real quick. This is a cubed, so it's going to look like this. And we know our zeros right here, they are at negative 3. They are at negative 1, and they are at 2. It's going to go up this way and down this way, and it's going to have 2 humps. So it's going to go here, here, and here.